Hi, geometry. We are going to talk today about the Pythagorean theorem and then the opposite of the Pythagorean theorem called the converse of the Pythagorean theorem. So, hopefully, you've heard the phrase or remember hearing the phrase Pythagorean theorem. And that's the thing that you see on chalkboards in every math teacher's, or honestly, just any teacher's chalkboard if you're watching TV. A squared plus b squared equals c squared. Well, what does that really mean? It means if you know you have a right triangle, then if you square one side plus square another side, it equals the square of the third side, where the third side is always the hypotenuse. And the biggest mistake that people make with the Pythagorean theorem is not knowing that these two have to be the legs, which are the sides that form the 90-degree angle. And this thing right here needs to be the hypotenuse. So a squared plus b squared equals c squared doesn't just mean, oh, just make whatever you want, a, b, and c. A and b have to be the two things that form the right angle, and c is the hypotenuse. So if we come down here and it says find x and y using the Pythagorean theorem, I'm going to look and say, well, the first thing I notice is I have a right triangle right here, and 4 is a leg, y is a leg, and 8 is the hypotenuse. I know it's the hypotenuse because it's across from that 90-degree angle. So a squared plus b squared equals c squared would be 4 squared plus y squared is 8 squared. And now I'm just going to solve. So 4 squared is 16, y squared, 8 squared is 64. I will subtract 16 and get y squared is 48. Square root both sides. And then 48 can be reduced. 48 is 16 times 3. So then I would get y equals 4 root 3. Okay. Then they want me to solve for x using the Pythagorean theorem. So I now know that y is 4 root 3, and they want me to find x. Well, there's two different ways I could find x. I could say, you know what? X is the hypotenuse of this triangle. So I could do a squared plus b squared equals c squared. Or I could say, you know what? X is a leg of the whole triangle. So I could say a squared plus b squared equals c squared. And I think I'm going to go that route so we don't have to square that radical. So I'm going to write this as 8 squared plus x squared equals, oh, what's my hypotenuse? Well, 4 plus 12 is 16 equals 16 squared. And then I would get 64 plus x squared is 256. Subtract 64. And I get x squared equals 192. And if I square root that, 192 is the square root of 64 times 3. So x is going to be 8 root 3. Okay. Now, if you're wondering, well, yeah, but what does that really mean in numbers? You can figure that out too. So when I came back here and I did y squared equals 48 and I square rooted both sides, if I was willing to have a decimal for that, I could just put it in the calculator and say, what's the square root of 48? It's 6.9. So y is like an easier looking number is 6.9. All right, a little bit more Pythagorean theorem. So I have Pythagorean theorem here. I've got a squared, b squared, and c squared. So I could say 3 squared plus 4 squared is c squared. 9 plus 16 is 25. And then square root them both. Then I have one more missing side right here for DC. A, B, C. 5 squared plus 12 squared equals c squared. So that's going to be 25 plus 144 equals c squared. That's 169. And the square root of that is 13. All right. So that's how Pythagorean theorem works. But the power behind Pythagorean theorem actually extends beyond finding the missing side. It extends to some other things. Now, one thing that I want to bring up is that when you do the Pythagorean theorem and everything's a whole number, that's going to create what's called the Pythagorean triple. And there aren't that many right triangles that have all whole numbered sides. Lots of them have radical sides or decimal sides. Whole numbers don't come up as much, but when they do, they're called the Pythagorean triple. So you can have a 3, 4, 5, a 5, 12, 13, and that's what we saw on this last page. We saw 3, 4, 5 right here, and a 5, 12, 13 there. And some other ones are 7, 24, 25, 8, 15, 17. And I think the next one after that is 9, 40, 41. Okay. You do not need to memorize these, but you'll just notice those numbers come up a lot, and those are called Pythagorean triples. Now, here's the thing. Pythagorean theorem only works if you have a right triangle, which means if you don't have a right triangle, Pythagorean theorem doesn't work. Okay, well, duh, how is that helpful? Here's how it helpful is. If the Pythagorean theorem doesn't work, you can actually tell based on it whether you have an acute triangle or an obtuse triangle. Okay, so the converse says if a squared plus b squared does equal c squared, then the triangle is a right triangle. All right. Sorry, there's an announcement going on behind me. Now, what can I do with that? If a squared plus b squared works, then it's a right triangle. What if it doesn't work? If a squared plus b squared works, it's a right triangle. If a squared plus b squared is bigger than c squared, then it's acute. If a squared plus b squared is less than c squared, then it's obtuse. Okay? Well, what does that really mean? It means if c is too big to be the hypotenuse, then you have an obtuse triangle. And if c is too small, then it's an acute triangle. I like to call this the Goldilocks theorem. Too big, too small, just right. Let me show you what I mean. So if I were to draw a triangle with sides of 6, 8, and 11, I would say, okay, well, 6, 8, 11, if this is a right triangle, it would look something like that. And a squared plus b squared, whoops, I didn't mean to write b, b squared equals c squared. Always make sure that the biggest number goes in for c, because that's the number you think would be the hypotenuse, all right? Well, let's figure it out. What is 6 squared plus 8 squared? 6 squared plus 8 squared is 100. So I have 100. And let's see, what's 11 squared? 11 squared is 121. Wait a second, those aren't equal. This number's too big. So since c is too big to be the hypotenuse, we know that this is an obtuse triangle. And this angle right here would be where the obtuse angle really is. All right, so if I come to b, these numbers aren't written in sequential order. So I want to look and make sure that the biggest number becomes our c. And I do a squared plus b squared equals c squared. And then just try it out. 7 squared plus 21 squared is 490. 22 squared is 484. Those aren't equal. This is too small, so we have an acute. All right, 2 more. Same thing. ABC. C has to be the biggest one. 33 squared plus 56 squared equals 65 squared. Let's find out. 33 squared. Too many squareds. Oh no. Plus 56 squared is 4225. And 65 squared, ooh, is also 4225. They work. It matches. When this is exactly as what it should be, I know I have a right triangle. All right, last one. 3, radical 6, radical 15. Well, which of those is going to be the biggest? Well, the square root of 6 would be between 2 and 3, and the square root of 15 would be between 3 and 4. So this is my biggest one. A squared plus B squared equals C squared. Squares and radicals cancel. So I have 9 plus 6 equals 15. 15 equals 15. That's another right triangle. And we are done. I hope you guys are having a good day. Let me know if you have questions.